Okay, so let's continue in our passing sight distance. Let's have our example. So compute the passing sight distance that vehicle A could move while overtaking vehicle B before meeting vehicle C. So the speed of car A is 27 meters per second. Speed of car B is 22 meters per second. Perception reaction time is 2.5 seconds. The average acceleration is 2.4 meter per second squared. Time the passing vehicle occupies the left lane is 9.5 seconds. And the distance between the passing vehicle at the end of its maneuver in the opposing vehicle is 75 meters. So let's solve again. Passing sight distance is the summation of the four distances. So isa-isa na ito pagkuha. Let's start with our d sub 1. So let's recall that t sub 1, our formula is v sub a minus m, t sub 1 plus 1 half a t sub 1 squared. So we already have our v sub a, which is 27 meters per second. And our a, or the acceleration, is 2.4 meter per second squared. And then our t sub 1 is the perception reaction time of 2.5 seconds. And then our m is again the difference of the passing vehicle and the overtaken vehicle. So we have a difference of 5 meters per second. So 27 minus 5 times 2.5 plus 1 half times 2.4 times 2.5 squared. Then we will be able to get a d sub 1 of 62.5 meters. Okay? Now let's compute for d sub 2. D sub 2 is again, it's just this product of our speed of the passing vehicle in the time that it occupies the left lane. So that is 27 meters per second times 9.5 seconds. So we will be able to get a D sub 2 of 256.5 meters. Now, D sub 3 is already given. So it's just the distance between the passing vehicle at the end of its maneuver and the opposing vehicle, which is 75 meters. Then D sub 4 is just 2/3 of our D sub 2. So it's just 2/3 of 256.5. So we will be able to get a D sub 4 of 171 meters. So summing this four distances, we will be able to get a passing sight distance of 565 meters. Okay, so that's how easy it is. So let's go to example 2. Compute the passing sight distance for the following data. Speed of car, 96 kph. Speed of overtaken vehicle is 88 kph. Time of initial maneuver is 4.3 seconds. Average acceleration is 2.37 kilometers per hour per second. Time passing vehicle occupies the left lane is equal to 10.4 seconds. And the distance between the passing vehicle at the end of its maneuver in the opposing vehicle is 76 meters. So I want you to practice it on your own. I'm just going to give you the final answer, which is passing sight distance for this is equal to 244 meters. So try to solve it on your own. Now again, careful of the values or the units of the given values. So what you should do. Nga, naka-KPH mo na siya. Okay, so kung na bahala how to explore that, basta ang final answer is 665.244 meters. So for multi-lane highways, there is no need to consider passing sight distance on highways or streets that have 2 or more traffic lanes in each direction of travel, as mentioned earlier. or in the previous video, passing maneuvers on multi-lane roadways are expected to occur within the limits of the traveled way for each direction of travel. So you'll just overtake on the lane that is, if you want to overtake, you'll just use the lane that is reserved for your direction. So that's passing maneuvers that involve crossing the center line of four-lane undivided roadways or crossing the median of four-lane roadways should be prohibited. No. Okay. Now let's go to intersection side distance. So intersections have the potential for several different types of vehicular conflicts. Side distance is provided at intersections to allow drivers to perceive the presence of potentially conflicting vehicles in sufficient time to stop or adjust their speed as appropriate. The side distance is also provided at intersections to allow the drivers of stopped vehicles a sufficient view of the intersecting highway to decide when to enter the intersecting highway or to cross it. So if the vehicle is from here, then that is his line of sight, and that Ganesha is a safe sight distance, and that should be clear. If on the other side of vehicle, so that is the line of sight. Okay, clear line of sight and a safe sight distance to the right. Okay. So departure side triangles allows for a driver stop on the minor road to enter the major road without conflicting with an approaching vehicle from either direction of the road. Sorry. So there are actually two situations now according to these two figures. That is a major road and a minor road in which this minor road is being controlled or it is uncontrolled or yield controlled lang siya. Well, here, it's stop controlled. Okay? So it has slightly lower uh sight distance compared to its A sub 2 or yeah, it's A legs compared to its B. So the decision point is the point for the driver if he's traversing, let's say, from here, traverse siya padulong dira, mosulod siya. This is a decision point for him to say nga, mo-stop ba siya? Mo-apply ba siya sa brake para makastop siya diri sa may intersection? Kay na ay, dili pa siya freely maka-cross sa intersection or mo-merge aning crossing street or crossing a road. So that is the decision point. So it should have a clear sight triangle. So actually, the recommended dimensions of the side triangles vary with the type of traffic control used at an intersection because the behaviors of the drivers would be different because of how you control those roads. So there are actually, how many cases is this? 1, 2, 3, 4, 5, 6. 6 cases, and there are also sub cases for some cases. So we have case A, intersections with no control. Case B, intersections with stop control on the minor road. Left turn from the minor road, right turn from the minor road, crossing maneuver from the minor road, intersections with yield control on the minor road, crossing maneuver from the minor road, left or right from the minor road, then case D, E, and F. So let's have case A. So case A, actually, from the AASHTO, it already have a tabulated length of side triangle leg depending on the design speed. Okay? So there are also adjustment factors depending if that said intersection have grade. Okay? So it's tabulated and against its design speed. That's actually also again based on the AASHTO 2011. This is indicated in the DPWH Design Guidelines Criteria Standards. Then we have case B sub 1, left turn from the minor road. So left turn from the minor road, the formula is 0.278 times the speed of the major road, or the design speed of the major road, times T sub G, or that is a time gap for minor road vehicle to enter the major road. So actually, according to some studies, they were already able to obtain the time gap. So time gap, this is conducted parang to see if passenger car usually, or according to this, there's some studies, it's 7.5 seconds, meaning 7.5 seconds siya makadecide na mo enter siya na nga intersection. So that is, again, it's just the product of these three values, 0.278 times the speed of the major road times the time gap. Then we will be able to obtain the intersection side distance. If English system, that is 1.47 times the, again, speed of the major road and the time gap, wherein the obtained value has a unit of feet since the speed is in mph. Okay? So already factors are already applied here. So just take note that if you will use this formula, your speed should be in kph. If this, then your speed, or in English system, it's mph. Okay? Not meters per second or feet per second. Okay. So let's say, let's have an example. A passenger car turning left onto a two-lane major road should be provided sight distance equivalent a time gap of 7.5 seconds in major road traffic if the design speed of the major road is 100 kph. So again, ISD is just equal to 0.278. So 0.278 times the speed of the major road, which is 100 kph, times time gap of 7.5 seconds. So you'll be able to get an intersection sight distance of 0.278 times 100 times 7.5, 208.5 meters. Okay? So if just we would just recall lang sorry, I'll just delete na lang. So that is 208.5. So if we will just recall the graph, so ISD is this one, the intersection sight distance that was solved in 208.5 muna siya nga distance. Now, what is A sub 2 nga distance? So actually, this one is just solve A sub 2 is equal to the A value is just equal to the intersection side distance over the tangent theta, the angle of your intersection. So when your intersection is just a right triangle or 90 degrees, then A is just also equal to your ISD. Okay? So that triangular area should be cleared. Now, just take note lang nga kani nga measurement from A sub 2 or even sub B should be at the center of the lane. Okay? Same with here. Same with here. Same with here. So it's also provided in the AASHTO, tabulated na nila ang values sa intersection site distance corresponding to its design speed if case B sub 1. And we also have case B sub 2 and case B sub 3. But their time gap is different. So any questions? That would be all for our site distances. So the rest of the type of intersections, we will not discuss it now further for this course. So let's just stop here in case B sub 1 and case B sub 2 and B sub 3. Same lang na sila formulas. Lahi lang ilang time gap. So I hope you will be able to understand the site distances and its importance in designing our highway. So thank you so much.